Why do clocks run clockwise? That is a question that I've been asked many, many times while I was teaching earth science in school. The answer might surprise you. The reason that clocks run clockwise is simply because they were invented in Europe and not in Australia. Well, wait a minute. Why should that make a difference? Well, to understand why that makes a difference, we have to go way back in time and look at some of the earliest timekeeping pieces. Some of the earliest timekeeping pieces were people that literally walked out and followed the movements of the sun. Where on the horizon did it rise every morning as we went through the year? And most of all, how did it cast shadows on the ground? So to know how it casts shadows on the ground, we have to utilize one of the earliest astronomical measuring devices, one of the earliest pieces of astronomical equipment that mankind ever invented. And that is a stick. But because we're doing science, we can't call it a stick because stick doesn't sound scientifical. We have to use a scientifical term. So in nerd, we are going to call this stick a gnomon. Gnomon, literally from the ancient Greek word that meant to know. This stick, this gnomon, was a source of knowledge for the ancients. Now this one's kind of blunt. We don't want it really, really sharp, but we don't want it too dull, so I'm going to cut it down a little bit to get it down to something of a point, and that will help us to make our measurements as we are moving forward. And that looks pretty good. Let me show you what to do. Come on. So, in order to be able to use a gnomon properly, we need a nice flat area. We need an area that has plenty of direct sunlight, and we simply have to stick our gnomon into the ground nice and level. And then we have to figure out a way, because this grassy stuff, we're going to have to monitor the shadow. This grassy area makes it kind of jaggedy, hard to see the tip of the shadow where the gnomon is being, the shadow that's being cast by the gnomon. So now we're going to set up a mechanism for monitoring the shadow accurately. Easiest way I know to do that is to take a board and simply put a mark right where the shadow is. Simple as that. So we're going to let this now run over time, and as this continues to run, I will come out a couple of times to double check the location of the shadow. We'll continue to mark it. Now, it is important that this board does not get moved. So make sure you can't take the board away and then put it back later. So if you can do this, it's best if you do it on some place that's permanent. I'm in a place right here where no one's going to touch the board, so we're good to go. All right, there's the beginning of my shadow. I'll be back in a little bit. Been about 15 minutes. I'll see you in about 15 more. Okay. There's our final mark. Notice what we have. We have a line that starts here, kind of to the west, and it goes through those three dots, and it moves toward the east. So the sun actually rises in the east, and it sets in the west. That means the shadow that's cast by our gnomon is going to be pointing west in the morning, and then it's going to move toward the east in the afternoon, because the sun's going to be setting in the west. What that does, if we put that on a circle, is what that creates is a clockwise movement. So if we were to put numbers to this, let's say 11 o'clock, 11:30, 12 o'clock. If we were to put numbers to this, then all of a sudden we have a clock. But if we were to use hands and spin this on a dial to follow that same pattern of moving left to right, then we have to spin it in that direction in order to get it. So what would happen if the sun, if we were in the southern hemisphere? Because right now we're in the northern hemisphere, and so the light is going to move in this direction. What happens if we're in the southern hemisphere? Well, in the southern hemisphere, our gnomon would be here, and we would have a shadow because the sun would be north of us, not in the southern quadrant of the sky, but in the northern. Because of that, the shadow would be cast toward the south. The south, there's north, let's say, okay? Well, that's north and that's south, then over here is our west and over here is our east. Since the sun rises in the east, the shadow of our gnomon would cast this way, but because the sun is in the northern hemisphere, if I were in Australia, that would cause the shadow to move in that direction as we move through the day. Thus in Australia, if the clocks were invented in Australia, they would actually spin in that opposite direction, or what we call counterclockwise. So the whole reason that clocks spin clockwise is simply because they were invented in the northern hemisphere. And there's the answer to your question.